Hello.
Hello. Wow,
Hey,
that's an amazing welcome
yes.
picture.
By the way, that's Murphy, my workmate's cat, and yeah, she's adorable.
Hello to Murphy as well.
So yeah, she's sleeping. I think she's with my wife at the moment. So yeah, both are like there are two cats, Murphy and Beanie. So they are like definitely playing with her at the moment. So
Awesome.
last night I was like going through a lot of docs and preparing for today's session. So while I was doing and she was sleeping, I thought of okay, it's a nice snap. I can take it. Yeah. So yeah, look at her. It's cute, right?
Teach the cats about EKS.
Yes. Maybe she was like dreaming. Okay, serverless. Yeah. Hey Zach,
Well,
so how are you doing, man?
doing amazing. How about you?
Seeing you after a long time. Just kidding.
Yeah, yeah, it's been like
Oh,
what a lot of days, man.
yes.
Damn,
Yeah. How was the reunion for you?
amazing. You know, I even met a good friend.
Oh, really? Oh, nice.
Yeah, yeah.
Your name is Zach or Shaf?
Yeah. So yes, the Zacks were at Reinvent,
Yeah.
and how was Reinvent for you, Zach?
Oh, it's amazing. Because so this year, like everything is like the main theme. I would say like make it simple.
Hmm.
So I think you already know about the KISS framework, right? Like KISS, keep it simple. And yes, so actually that's really good because um, I've been learning about that a lot about like how you can keep it simple, like rather than over engineering things, right? So
Hmm.
keep it simple, which is cool because you don't have to you don't have to over engineer things. Always like think in the simple way how you can get it deliver and make it happen in the best ways, right? So that's one of the things about the technical stuff. And I would say my main thing about the community, man, like I really loved it. Like it can be the heroes program, it can be the community builder, and the user group and everything. So it's like I met a lot of people. I think you and me like being together always on the reinvent. So we met a lot of people, and everyone was like, okay, hey, Zach show is nice and we would like to do a session there, and we got a lot of names and contacts, so definitely we can
Spoiler
uh,
warning! Spoiler warning!
spoiler warning, and we definitely will be inviting them. And it was amazing. I would say like community, man, like even we both know each other like because of the community, right? So I would say community, just give back to the community. Yeah, it's
Yeah,
amazing.
yeah, and it's also your second reinvent, and the
Yes.
very first one as the hero from New Zealand.
Yeah.
Yeah,
Yes. Kira for all the Kiwis. Yes, I'm really proud about that. Representing Ontario, New Zealand. So yeah, I would say a proud Kiwi moment.
awesome. So
Cool.
here's one thing about reinvent.
Yes.
We had tons and tons of announcements. Of course, AML also, and a lot of other things as well. So
Gen
one
AI.
of it, yeah. It's all over the place.
Yes.
And one other thing that we are talking about today, I know you'll really, really love it. It's
Yes.
something of your expertise as
Is it
well.
working?
So, yeah.
Is it working? Oh,
Yeah.
oh, come on, Apple, come on. All right. Oh, how come it doesn't work for me? Oh, all right.
Yep. Kubernetes, it is.
Yes.
And
I think maybe I'm screen sharing. That's why it's not working. So we are going to talk
mhm,
about Kubernetes, especially Amazon EKS today, because I think this is a major release from Amazon. Um, if you love Kubernetes and if you're using EKS, this is a major thing because Personally, I know because I day to day I work with Kubernetes and EKS, so this can solve a lot of problems. Um, and we're gonna deep dive and we're gonna talk about this. So, drum roll, Zach. You're gonna.
So yeah, the stage is yours, Zach. So
Cool, nice. Okay, so today we are going to talk about EKS Auto Mode. So if you have been to reInvent, if you missed this session, might be this really useful. And if you've been in this session, it's going to be really useful because we are gonna deep dive and we're gonna do some hands-on demo live. Hopefully, demo goes with me. Yes, and um, yes, so you can see the link about the EKS Auto Mode. So this is a launch blog. I mean the launch, the article or whatever. So you can see here, but we are not going to go through this because we are going to go deep dive. Cool. I have my robot here. So usually, when we create an EKS cluster, and basically it's not ready to deploy like production class applications. For example, for a application, you need a deployment, and with that you need ingress. So ingress means like how the customer is going to, or user is going to access your application from the outside, right? So you can have multiple ingress classes like ALB, NLB, or Nginx, or some other things. So if I draw an iceberg like this, okay, it's very bad. My drawing is really not really good. And I am gonna draw a shape. So there's a small shape here, and you can see both Zachs are here. So if you're talking about Kubernetes, we are seeing only this part. Like everyone's saying, Kubernetes is easy. Kubernetes, you can manage everything. Kubernetes, just deploy application. Kubernetes will do the magic. And magic, we have really good demo later. So when we're talking about magic, yes, we are seeing only about this. So basically, if you're using a managed Kubernetes version, so let's say EKS. So EKS, we get the control plane, right? I'll write as control plane CV, and you can deploy with node groups, and Amazon supports manage add-ons. So add-ons basically behind the scene. If you're hosting a Kubernetes cluster as EKS, you can't just deploy and work on it. You need add-ons like plugins to get things done. So we have like two plugins. So one is the kube proxy. So it will make sure the connectivity between the ports, if you have multiple nodes, so connectivity between all the applications, the kube proxy will make the connectivity. And we need a DNS, right? So yes, so core DNS will make sure we show the DNS. And we have kube proxy and core DNS, and we need something network layer, right? So we have VPC CNI, so container network interface. So each pod needs an IP address. So VPCNI will make sure, okay, from the subnet, it will release IP address for each pod. So these are like main add-ons you need to run if you're hosting your EKS cluster. And there are so many others. Like you might think, okay, we have other add-ons, and those are also really pivotal to run this cluster. Yes. For example, CSI drivers like EBS volumes and external DNS, cluster autoscaler for node scaling, so many things. So behind the scene, there are so many things are running under the sea. Like you can go deeper. So let's quickly go to this. So these slides, these screenshots I took from the official reInvent announcement. So it's public available. Zach will be sharing the link with you shortly. So if I go here, okay, cool. So this is how a current EKS cluster setup looks like. So we have the EKS account, which means like Amazon will be taking care of this side. So the API server instances, etcd databases, everything will be managed by Amazon. But rest of the things we have to manage as customers. So we have to make sure the add-ons like plugins I was talking about. So here we in this image it says Carpenter. So if you want to scale your EC2 instances, like node scaling, like a data plane layer, so you can scale with Carpenter or Cluster Autoscaler, and pod identity for like for your pods, and we have the VPCNI, we have the code proxy, and I can talk about like multiple add-ons at the moment. Like if you go to the CNI CF landscape, there are multiple add-ons which are cloud native. You can run it on EKS cluster. There are so many. So, and the main part we have to understand these things we have to manage. So managing add-ons also you can use like GitOps using Argo CD. You can make sure like everything's up to date. And if you have multiple clusters, you can use GitOps to make sure everything is deployed in each cluster, up to date, and you can maintain it. So I'm not going to go deep dive about that. We can talk about that in another session. So we are going to talk about only about EKS auto mode. And main thing we have to understand that we have to, as customers or users, we have to maintain this. If you're a developer, you have to maintain this. It's very hassle, right? Like it's very painful. Personally, I know like how painful it is. And EC2 instances. So this is another one. Because if you're spinning up EC2 instances, you need to have AMI. And AMI is operating system, and you have to patch it, and you have to keep it, manage it. And when you upgrade the clusters, you have to make sure you have to update the nodes as well with the right version. Maybe there can be a security patch, so to make sure EC2 instances are up to date. So it's really painful if you have like multiple, like 100,000 EC2 instances. It's not easy to manually doing it. And a few more other things like network load balancers or application load balancers for the ingress I was talking about. And if you're using persistent volumes, you have to use the EBS volumes or EFS, so on. So let's quickly go to this layer. Yes. So this is up to now where the AWS is managing it. And here we have to, as customers, we have to manage these things. So you see, we have to manage a certain level, I would say like layers, you have to manage it up to now. And the bottom three layers managed by the AWS, which is the control plane, and like foundation services like compute, storage, networking, monitoring, and global infrastructure like regions, local zones, its locations. But the life cycle and operating system, everything, we have to manage it. Even though if you're using the EKS AMIs, we have to make sure it's up to date here, and you have to patch it. Like you have to relaunch new AMI and evict all the pods to the new instances. So monitoring, health, and repair, everything you have to manage it. Cool. So before I go to the next one,
can we call this as a shared responsibility model for EKS?
Yes, definitely. So thank you, Zach. I totally forgot to mention that. So this is a shared responsibility model. You can see it's like according to this one, like 50-50, but it's differs. But yes, definitely is a shared responsibility model. So before we go ahead to this, and I want to show you, I have created two clusters. So we have Hogwarts, the full magical one, and Muggle like Jones. I'm so sorry, Jones. I know you love Harry Potter as well. So just kidding. So we have two clusters. And the Muggle one can see its EKS disabled. And the Hogwarts one, we have auto mode enabled. So auto mode enabled and disabled. So we have two clusters different way. So let's go back to here. Cool. So I hope everyone understand what currently at the moment like EKS offering. And quickly we'll slide it here. You can see the share responsive model, it's been changed a little bit. Nice. So this is the exciting part. So you can see from EKS account, like from AWS side, they manage as usual API server, HCD instances for the HCD databases, and for three key part of the cluster: storage, compute, and networking. So storage is mainly for like persistent volumes, and basically if you are spinning up a pod, a deployment with a pod with shared storage, so basically you can spin up with the EBS volume. So compute, behind the scene, they're using Carpenter. I really love Carpenter. Definitely we should talk about Carpenter in another session. And Carpenter is really intelligent. So basically it can figure it out. You can configure Carpenter to run with different compute type. Like for example, Zach wants to run some GPU related, GPU intensive workload, and Carpenter will find the right, perfect, most cheapest instance for that. Even though it can be on demand, it can be spot instances, like different kind. But I'm not sure whether it supports spot at the moment. I haven't tried it yet, but definitely when I tried with it, we can tell to our audience in our next session. But Carpet is really intelligent. It will find out the perfect, the best compute instance for your workload. And not only that, so initially, for example, it might be spin up with a large instance, but later on, it will do a cancellation, like it will slowly find out, okay, these pods are underutilized. Maybe I can go for a very small instance type. So it will do something like that. And not only that, if you have multiple type of workloads, it does something called bin packing. It will try to put most of the pods in one node, like pack it together. It will like utilize very well that instance. It won't like overutilize it. Sorry, underutilize it. So that's the compute part. And networking, it will take care of the core proxy, core DNS, and the LB ingress, and VPC, all the networking part will manage as well. So you can see here, this entire part now managed by AWS. So here we have to manage it. So see, right? So customer account, basically it will, so when you create a ingress, it will create we can select which ingress I want. Like for example, it's ALB or NLB, it will create NLB or ALB for us. And for persistent volumes, it will create persistent volume. So later on, we will be testing this out in our demo. So you can see is a bigger part here is now managed by Amazon. How amazing is it, right, Zach? So for us, like, okay, let's work, we can focus on. It's not about the cost, because even the Carpenter can find a perfect workload for you, like, I mean, the compute for you to run, but it's not about only the cost. So I was listening to the Todd's talk. So he mentioned about the engineer work time. Yes, because if you have to manage all these things, it takes a lot of engineering time, and engineers can focus on other things, right? If you have something like this, engineers don't have to worry about the storage, the compute, and networking, all these major add-ons. Engineers don't have to worry. They can work on the other things. So it saves times for the engineers, which is really help for the organization to save a lot of cost. So it's not only about the cost of the cloud bill, but the time as well. So here we are talking about the shared responsibility model for the current setup. But if you go here, see, right, the customers has to worry about only this area. The rest is taken care of about AWS. So this is really amazing. So that's why this is my favorite launch at AWS, reInvent 2024, because as a person who is working with containers and EKS, I know like how amazing this is. But to be honest, there are a lot of improvements that has to be done, and definitely there'll be a lot of things hopefully coming up in this year. But for now, you can spin up a cluster and just deploy your workload, and we are going to test it out in our demo. How cool it is that? Any question for you? Oh, yeah, I can't hear you. Sorry. It's all right. Sometimes we get hello. Oh, you're mute, and I think you're soft mute. All right. So while Zach is sorting out his mic, no, still I can't hear you. I think maybe you can drop off and join back. Cool. So while waiting for Jones, let's talk about something else. And the EC2 instances are managed by BotRocket. I hope you're familiar with BotRocket. If not, it's an operating system like mainly optimized to run containers. So it's managed by AWS, and you can see sorry, you can see the GitHub link. It's open source. Sorry, you can go and contribute if you want to the BotRocket. It's amazing. It's a very lightweight, and it's fully managed operating system for containers. So I think Zach is back.
Yes, I'm back.
Nice. So I was talking about the BotRocket, about the container, the minimal container operating system based on Amazon Linux. So, yep. Cool.
Awesome.
Nice. I think it's time to go to the demo, right?
Yes, sir.
Cool. Let's go back here.
Time to put on my muggle hat.
Yes. So even though like even though a container person, I had this doubt like, okay, they're talking about how these things are managing, like, they mentioned like they're going to manage the storage, compute, network, these things, and all the add-ons. So what I did as a like this cat. Oh, where's my cat? It's gone. Oops. Sorry. Cool. Like a curious cat, I was also like curious what's going on. So what I did, I created two clusters. So a Muggle with the old way of creating the cluster, like, still, I mean, not the old way, like, without the EKS auto mode, I just disabled it. So if I go to my terminal, kubectl, get ports in all namespaces, you can see the AWS node, the pod is running, which is the VPC CNI and the containers, and core DNS, core proxy, and everything's running. So these are basic, like the default EKS cluster. And if you go here, and you can see the same. If you go to the resources in the Muggle cluster, the pods are running. And if you go to the cluster and the nodes, you can see one node is running M5 large because two M5 large are running, and which is the node groups is created by myself. And yeah, it's very static. So I mentioned like I need M5 large and it's running M5 large. Cool. So you can see a lot of things here, right? Yes. Let me go to the Hogwarts cluster. So say if I go back here, the same version, no difference, same version. I go to the Hogwarts cluster. I'll go to the resources, and no pods at all. So what I'm going to do now, I'm going to change cluster to Hogwarts. It's nothing running. Go to CTL, nodes, no node at all. So if you go to the the console, you can see nodes, nothing running. So basically, you can't see anything here because it's managed by Amazon. So AWS, yes, Amazon, and so basically these add-ons are like running inside these AMI like instances, like agents. So you can't see any pods running like that. But if you go to this cluster, the Muggle old one, you can see the add-ons. These add-ons are running, like managed add-ons are running inside here. So if I go back here to the Hogwarts, which is the cluster, we have enabled EKS auto mode. You can't see any add-ons, nothing. But magically, everything is managed by Amazon. Cool. So what I'm going to do now, okay. I love this ID, Zach. It's so cool. It's called WAP. It's based, yes, WAP. It's so cool. So I have two manifest files. So manifest.yml and STS. STS means stateful set in Kubernetes. So if you go to the manifest file, I have a deployment. So Zach show deployment, yes. I'm going to deploy 36 replicas, which means 36 pods. And I'm going to create a container. I have my own container in my public Docker Hub, like Dogo app. And I'm going to create a service called Zach show service. And I'm going to create an ingress class. I'm going to annotate here with ALB. I'm going to ask EKS cluster to create me a ALB ingress. Cool. And I'm going to create an ingress as interfacing for my service, Zach show service. Okay. Before we go ahead creating this, I want to show you something else. If I go here, if I go to create cluster, see, even the UI change. So even the UI now supports, either you can go custom configuration, you can, even though you can enable EKS auto mode and you can customize a lot. But if you're going through the easy mode, like quick configuration, you can, so it's nice. It generates a random name, but Hogwarts and Muggle, I put that name myself to make it fun. And one more thing, EKS auto mode only supports from 1.29. Up to that, like 1.31 is the latest version EKS support for Kubernetes. The upstream is, I think it's support 1.32. So this cluster IAM role and node IAM role, these things are, I created already, but this is really amazing. Just you click here. If you don't have, it will use the best practices and it has all the configuration. You can just basically create these things with the relevant policies and it will create a role for you. So since I already have it like that, and the subnets
probably do that recommended role for all services.
Yes. So that is really amazing, right? Because it's granularly configured, like which are the permissions you want, and everything is perfectly done. Cool. So and subnets and everything. But if you're deploying an EKS cluster on a VPC, you have to make sure these things are really, really important to understand. You can't just create a VPC and you can't just deploy it. You have to make sure these things are there, because there are specific tags to be tagged the subnets, and without that, it will fail. If you're trying to create a EKS auto mode in your, if you're just creating a VPC and just going to deploy, especially for the ingress, it will fail. So you have to make sure you're creating the VPC for your EKS cluster with the best practices. So I'm gonna put this here, and cool. So John's gonna share that one for you. Nice. And you can just create the cluster. Cool. So done with that, let's go to the demo. Okay. So I'm gonna create 36 container replicas, and I'm going to apply here. But what I'm going to do now, I'm going to kubectl get node pools. So Carpenter, if you're familiar with Carpenter, you know what is node pools, but I'll briefly explain. So node pool configuration, you can configure which type of nodes your workload's going to be running. So by default, you get general purposes and system. So system is basically the node pool that will run like critical workloads of your cluster. And general purposes, you can run workloads and you can create node pools as well. So as per my understanding, when I go through here, so manage node groups, wait, EKS auto mode, how it works, and run workload. Okay, sorry. You can configure the node pools. So you can configure which type of instance type you want to work, and everything will be there, and you can configure the node pools. Cool. So by default, we have 2 node pools, and I'm gonna get kubectl get node claims, node claims. So currently I don't have any node claims and I don't have any nodes. Cool. So what I'm going to do now, I'm going to apply this workload manifest.yml, and I'm going to get node claims. See, without 2 seconds, it's created a general purposes node claim, and it's already ready within 8 seconds.
Wow.
How amazing is that?
That's
yes.
fast.
So which means you can zero scale, right? You don't have to run anything. The current setup, you have to make sure the Carpenter pods are running inside the cluster. So at least you have to make sure at least one node is running always to run Carpenter pods. But here you don't have to do anything. So it's zero. From zero, you can scale. So it's running a C6A X large and on demand. But if you're running for a long time, and you will realize, depends on your workload, it can scale in, like scale down your instance type. Depends on the workload. So you might think, okay,
so it chooses the best instance type.
Yes.
Is that right? Nice.
Yep. And it's ready already. And let's see. Let me get my deployments. So I'm running in everything in the default namespace. So within 69. Okay, less than 69 seconds, definitely. All my pods are running. So kubectl get pods. So all pods are running at the moment, which is amazing, right? And I will get my service first. So this is actual service we created. It's running. And I'm going to get my ingress. Cool. So already ingress is created. Let's see whether it's... So the thing is, the DNS propagation will take some time. And while it's going on, what we can do, what I'm going to do now, I'm going to check in this tab, kubectl get nodes. Only one node is running, right? So I'm gonna get deploy. I'm going to scale the deploy maybe to, oh, just hide it, please. Oh, I hate this screen sharing thing. Okay, maybe we'll go to 60. Don't need to be very harsh. Cool. So slowly scaling, and so it's scaling here. I'm just checking the events. Okay, 56. I'm gonna check the nodes. Ooh, there's another node is created because it needs more resources. So it created another node within like 8 seconds, and 56. It will take some time to get the node ready, but not bad. So it's a C6A large instance. So by the time, as you see, right, it's a X large, and by the time, how Carpenter works is like it will, it uses algorithm to find the right the capacity, and it will figure it out. Okay, maybe it's underutilized. It will use a very small instance and evict all the pods to the new one, and which you can save your cost a lot. Cool. And if I get the deploy, nice. All 60 out of 60 my pods are running now. Cool. So I'm gonna dig. It's the same ELB, not sure, but let's go here. Sorry. Sorry, HTTPS. Oh yes, our dog app is running.
Awesome.
So you see, right? I didn't do anything. I just spin up a cluster. I spin up the cluster earlier because spinning up, it will take around like 10 minutes. I think it's going to be, I mean, it has been optimized a lot. It used to be more than that, to be honest with you, like when I spin up cluster like a couple of years ago. But I just spin up the cluster using EKS command, and with auto mode enabled, I just created this very small YAML thanks to Amazon Q. I just ask, yeah, I just created using Amazon Q. I just ask it to like create 36 replicas with this, and I have to create this ingress and everything. It's created. So you can see already it's running. My pod is running, and it's healthy. Doggo is like rotating. So it's super fast, and it's production ready. But there are things we can talk in with few minutes later. I want to show a couple of things. So we can talk about like what are things that as developers what we're expecting. I'm quite sure Amazon is always listening to the customers, and they will definitely deliver those things as well. So if I go to kubectl and API resources, you can see available resources here. And most of the things I want to show, basically the security group for policies is already, it comes with the out of the box. And where's the network part? So the ingress is there. And yes, so the ingress and the CSI drivers, and most of the things like it's already inside, but the thing is we can't see because it comes with the node level, and we can't see anything like pods running inside the clusters like what we checked before in our Muggle cluster. Like here, you can't see this thing inside the cluster because It's managed inside the node level. AWS is managing it for you, so why you have to worry, right? Because they're already managing it. See, so if you can see here, if I go to the replica, sorry, deployments, it's only my deployments there. It's healthy, 60 pods, and no stateful set, no daemon sets are running as well. Cool. So we checked already about the LB. So what I'm going to do now, I'm going to apply the STS demo. So STS, I just basically got it from the Amazon docs. This manifest file, so basically it's creating a storage class with EBS and a persistent volume claim and a deployment with a persistent volume here. So I'm going to deploy that. And if I go to kubectl, get STS, sorry, get pods. Okay, still container creating because I'm going to the persistent claim. So persistent volume claim is here, and I'm going to check 24 seconds ago. I'm going to check the get the persistent volume. Cool. So kubectl describe pb. So I get the volume ID here about of my persistent volume. So I'm going to go to my EC2 volumes. Cool. So Zach, where can I see the time? Where can I see the time? creation time. Oh, the interface changed.
Yeah.
So basically,
created Jan 4th, 21 hours. Yeah.
oh, here, yeah, yes, cool. Yeah, so here. Yes, so that's my time. You can see here. Oh, it's covered by our logo. So if I can move it. It's fine. So the New Zealand time is now 9:43
Yeah, it's
p.m.
43
So
and
yes,
it's 1 minute back. Yeah.
1 minute back. So it's super fast and it's created. And if I get sorry. Wait. Sorry, I'm creating a deployment, not a stateful set. My bad. So it's a deploy. Say stateful set is running now. So the volume also healthy, and you can already see here the volume is running. So I didn't install any drivers or anything. So everything is inbuilt, and it comes with the EKS auto mode. So things we have to understand here mainly, you can just spin up a EKS cluster with EKS auto mode, which is like ready to go with a couple of things. So if I go here, I will see. So application load balancing, block storage, compute auto scaling, even the GPU support for your machine learning work stack if you want to mine things, just kidding. And the DNAs and pod and service networking. So you remember, right? The pod identity and a couple of things are all running inside. So yes, so these are the things currently at moment supporting, but there are things can be support in the future. I hope so, like KDA. That's one of my ask from AWS. So hopefully, because we have Carpenter now for the node scaling, for the pod scaling, if they can support those things, that would be amazing. And hopefully we can see those things in the future. So how do you think about this new feature?
Amazing.
I was
Because
talking a lot, I know, because I was
Yeah.
super excited, man. Come on.
you were in the flow and I didn't want to disturb you.
Yes.
Yeah, it's really an amazing update. One reason why I always think of serverless first is the ease of doing things, right? Like I can
Yeah.
focus on my own workload or the logic that is there instead of worrying about the infra. But auto mode kind of solves it. So interesting, and I really want to get my hands dirty on that. But that's said and done from me. But you have a few questions, and I did see uh, two of them really appreciated the demo and the whole way how you explained about auto mode. So LK Ravi Tech Show has a question for you, and
Yeah, looks like it's reduced a lot of operational overhead. Looks like auto mode not allowing direct access. Yes, that's a very good point. I was keeping for the end. So if you go to auto mode here and troubleshooting, and can see, so yes, so you cannot directly manage. Yes, I think that is one of the reason that it's a managed service, I would believe, because yes, and that's why they're not allowing you to log into that cluster, log into that nodes and check it. For example, if you're running your cluster with like cluster autoscaler, you can SSH into it and you can manage it and everything. But at the moment, EKS Auto Mode is not supporting directly access your things like, yes. So that's why they're suggesting like if you have any problem with controller, you should research these things. Yeah. Is this
awesome.
node? No, the nodes are running in our VP. So if I go here to my EC2, so these are the nodes running at the moment. So there are, okay, forget about these nodes because these are like Muggle nodes from my from this cluster, but these are the nodes running from EKS Auto mode. So if I go to here and AMI name, you can see EKS Auto standard 1.30. And I almost forgot the best part about it. Almost forgot. Thank you, Ravi, for asking that question. So I'll go here. So let's talk about cluster upgrade, Zach. So that is one of the major thing. Like if you're running cluster and upgradings are really painful, and upgrading the control plane and things are easy. I mean, like you can just one click you can do it, but the add-on upgrades and everything's are really painful, like major add-ons, like like VPCNI, Core Proxy, Core DNS, those things. So I did some testing yesterday, and I just run this command to get the nodes, and you can see kubectl get nodes, and it's running 1.30. So what I did here, you can read the text, right? Is
Yep.
it readable?
Yeah.
So I just upgraded the cluster, my Hogwarts cluster yesterday, and to 1.31. So EKCDL, everything's done, it's up to date. So then I was watching my nodes. You can see here, it's created this new nodes 1.31, and gradually it evicted all the pods from the old nodes to the new one. So doing eviction, there are certain things we have to concern, like pod disruption budget. So if you go here, click CDL, so the PDB, I will grep. So if you're configuring your pod disruption budget, how the pods can disrupt while it's evicting, so you can make sure you have good resilience on your application, so there won't be any downtime, and the Carpenter, with respect, the EKS Auto mode, which comes with Carpenter, it will respect your pod disruption budget, and it won't just evict your pods by force. So it will respect the pod disruption and the node disruption, and it will gradually migrate your pods to your the new nodes from 1.30 to 1.31 when you're upgrading. But as engineers, you have to make sure you have to write your application on containers to make sure it can be disrupted, right? Because containers meant to be recreate anytime. It should be able to restart multiple times per day. So make sure you write your application should be able to handle these things. So it should be able to disrupt. So if you're writing an application which is not supporting disruption, so it's something you have to think as engineers. So make sure that's one point. When you write an application, make sure you should be able to disrupt if you're running on a Kubernetes cluster. So this is the screenshots I took when I upgraded the cluster from 1.30 to 3.1. I didn't do any manual pod migrations like pod evictions. It did everything automatically because Carpenter is really intelligent. It will detect the drift detection that I have upgraded the cluster to 1.31. It will upgrade the nodes as well. So new EC2 instance created within 1.31, and it migrate all the pods. So how amazing is that, Zach?
Pretty brilliant. And how long did this take?
So it took a couple of minutes. So that's why, because the cluster upgrade, it took almost like 10 minutes, I would say, because I ran this one like 10:49 and see. So it took like 10 minutes to upgrade the cluster, which is not bad, to be honest. But Carpenter will wait for a while, and you can configure all these things in your node pool configurations, and the drift detection will work gradually migrating these workloads. So these like 3 nodes, but imagine if you have like 100 nodes, it will do one by one gradually. But to do that, as I asked before, as from software engineers or you're a front-end engineer or an engineer, just make sure you write your application the right way to handle, run on a container platform. Yep.
Awesome. Wow, that was an amazing demo and a lot of information for me. So yeah.
Yeah. It's a non-container guy, yes, a lot of information, but definitely if you're an EKS person, like, yeah, this is amazing.
Awesome. There was one other request.
Yeah.
Okay, yeah. Can you make a video on Gardener tool for Kubernetes?
Oh,
Gardener Cloud.
cool. Maybe we can. Why not? What do you think?
Awesome. Yeah.
Yeah.
You're the Kubernetes guru, so yeah.
No, I know so many Kubernetes gurus. Like, maybe I can invite one of them.
Yeah, that's
Yeah.
some fun thing.
Yes, I'm gonna take a screenshot of this, and yes, I'm gonna invite one of them, so we can talk about more Kubernetes.
Yes, sir.
But I don't know. After the reinvent, I'm kind of like my brain says Kubernetes, but my heart says go to serverless. I don't know. Like, I'm start loving serverless now.
Serverless team is waiting for you.
Yes. Cool. So I think we did a really good session today with like almost 1 hour. Wow.
Yeah, when you have an amazing speaker and they're really hooked on to what is the exciting part of this session.
Yes.
So yeah, you can. Time is just a number that's running.
Cool. So if you want to create the cluster, and I'm going to publish a blog about this maybe next week.
Ooh-hoo.
Because I'm still enjoying my Christmas holidays, so no time for that.
Enjoying your summer Christmas holidays.
Yes. And yeah. So this is the command. Zach will in the chat. It's very simple. And if you have multiple profile, you can use the profile. I'm not going to teach about how to use the AWS CLI commands. But if you have a question, definitely you can ask. So, yeah. Cool. So basically, you can get the cluster if you have to install EKS CTL and create cluster, and you can use the your console as well. But this is I love the command line. So it's very easy. It's a single line. I created this cluster. I didn't do anything at all, and this I created my manifest using the Amazon queue, and I just kubectl apply. That's it. That's it. Trust me, that's it. I didn't do anything. I'm not cheating because I'm a very honest person. So I didn't do any cheating. I just created the cluster and generated my YAML with Amazon Q. I prepared last night within few hours, not even an hour, to be honest with you. While
That's
I
the
was
right
watching a
use
movie.
of GenAI.
Yeah, yes, exactly. While we were watching a movie, actually, yes, cool.
I guess that was a Harry Potter movie.
Actually, it's a Korean movie. My wife is into more Korean stuff these days. Yes.
Awesome.
Cool. All right then. And thank you so much. And hopefully we'll be seeing you again with another, maybe another Renote announcement or something else.
Yes.
Interesting.
Yeah, I mean, there's amazing stuff out of reinvent and
Yeah.
pre-invent and
Yeah.
out of the both of them. So
Yeah.
yeah,
Cool.
that's awesome.
So just create the cluster. Yes, Ravi, just create the cluster and let me know if you need the ML. Definitely, you can generate from your Amazon Q, and you only know what to do, and you can create your own thing as well. And yeah, give it a try. It's super amazing. And yeah, I just managed to scale from 60 pods to like 600. Like it takes time because I just suddenly asking for like 600 from 60. So it took some time to scale up. Cool. All good then. We'll see you with another
At
Zach
the
show.
show. Yes. Thank you all. Thank you, Ravi and Chaitanya,
Yep.
and everyone else who were part of it. So awesome.
Bye
Until
bye.
next time. Bye
Yep.
bye.